Yes, and we have a very important announcement. So finally, Cozystack was added to landscape.cncf.io. You can find our solution there, and it's a big leap forward because more people will know that we exist and will try to check what Cozystack is it.
Yeah, cool. Thank you for this announcement. I almost forgot about this. So everyone, welcome everyone in our weekly community meeting. I have to repeat that we have Telegram group where you can join and ask your questions. We also have Slack group in official Kubernetes Slack. You can ask your questions there. And do we have any new members in this meet who would like to introduce yourself?
I guess I should introduce myself. My name is Timothy Larkin. I've been helping to maintain the etcd operator repo for a while now. A lot of people here know me.
Yeah, Timothy is implementing main functionality for our etcd operator right now. He is currently working on adding functionalities for automatically recovering the failed members and bootstrapping the cluster itself, actually. Okay, then we just introduced that we added to CNCF landscape. There is another announcement that we were on TalosCon previous week and recordings just get published. There is a playlist for from Talos conference. There are a lot of interesting talks. And there is our talk about building a bare metal platform with Talos. So it is talk especially about the Cozystack. And we have upcoming Cozystack 0.16 release. There will be few changes. The major changes alerts has been added. So we added additional dashboard, which called Alerta, and it will deduplicate and show all the alerts, so you can see what exactly go wrong. And most important, it has a really cool integration with Telegram. So you can get alerts and you can immediately click that if you got hack on them, or you can close and enable various maintenance mode for those alerts. Also, we updated the Grafana to the 11th version, and all the dashboards with it, they're actually the same dashboards, little bit reworked. So some plugins has been changed. Now are they working on the newer Grafana version? And what else? Also, there were big change to update all the Kubernetes components. First, we moved building of all the images to the Docker, to the Cozystack repository. So Cloud Controller Manager, cluster-autoscaler, and CSI driver now will be shipped together with the platform using official images like in this repository. This change also introduced the new feature. Now we will support external traffic policy local. The problem that previously it wasn't supported because the cloud controller manager for KubeVirt was very stupid. It was just routing all the traffic to the node group of virtual machines. And now it is more smart, so added additional controller for getting information where exactly on which node, on which virtual machine the service is running, and then it will route traffic directly to it. This mode also enabled for external traffic policy cluster. So I guess in many cases, you will get better throughput if you run your workload in tenant Kubernetes clusters. There were also some Flux-operator and Flux chart updates. I think Kingdom can share more information about this. I didn't get what exactly changed. I just saw that a version get bumped. Thank you for this community contribution. If you have some information about the changes, could you please share?
Sure. The basic thing that happened since 0.7 is there's a Flux instance chart that's been created upstream. So that is something that we built ourselves here in Cozystack as a stopgap before that was available. And now we're using the Flux instance chart from upstream. The second thing that's changed is there's an artifact, OCI artifact configuration that it's part of the new version of Flux-operator that just makes it easy for, so you don't have to get a new version of Flux-operator in order to get a new version of Flux. So in the previous version, we would have had to do some upgrade upstream so that the new version of Flux-operator is installed before anyone could upgrade to a new version of Flux. But now if they set their Flux version spec to 2.4, then they'll get Flux version 2.4 as soon as it comes out, probably on Monday.
That's so cool. I think we can wait until this version will be released, and I would like to include it into Cozystack next release. So I think we can make this release on the next week. For now, we will just test that all the things are working. Then we will just update the Flux CD and make a release, I think, on the next week.
Super.
Thank you for the update. That's all from the agenda, and I think now we can discuss a few things. We still need some help from the community. Sometimes we ask some questions and get really useful responses for this. And maybe someone could contribute to the project and provide the more code stuff actually, which they get used to use in their infrastructure systems. The main topic for now are alerts. So the alerts, the only basic alerts from Kubernetes Prometheus stack get included. Actually, those alerts get converted to Victoria metrics chart, and now we included it in Cozystack. Maybe you know some other good sources of the alerts which we can just import for now, or maybe review it a little. So just share any information. What would you like to monitor, and where can we get those alerts? I think that we need to monitor at least Helm releases from Flux, because it is the main, the core. The Flux is core of our platform, so we need to know the status of every Helm release getting deployed. So I think those alerts will be included in this release, and I would like to add linstore alerts, because the storage system is very important. And it is not always good if you have not enough replicas or some volumes which are broken. Maybe is there anything else which we need to monitor? No ideas.
What about the etcd cluster? You can monitor it?
Yeah, that makes sense. etcd cluster is the core of our Kubernetes cluster, so we need to enable those alerts. I think that might be also good point to get contribution to etcd operator project to add the dashboard and alerts for etcd operator, and also then adopt them to the Cozystack.
I think some kind of service monitor would be perfectly sufficient for that. But yeah, the operator could generate credentials for the monitoring system to access it.
Yeah, that might be not very easy to monitor etcd, because it expects that all the requests will come using certificate. Am I right?
Yeah, that's right. But I don't think this should be a problem because that's generally supported. Maybe we have to think. Maybe it cannot just directly read a Kubernetes secret from the relevant namespace, and it has to be specially mounted in some way. I'll have to take a look at that. But in general, VM agent or Prometheus or whatever is perfectly capable of using certificates to authenticate against an endpoint.
Thank you for this information. I'll take a look on this.
From my point of view, you are totally right that we need two types of alerts. First type of alerts, it would be alerts based on Helm releases in case if something was deployed incorrectly. So we need to check that upgrading process did not introduce any misconfigurations or failing releases. And the second thing is a state when platform is operational, we are not introducing any changes into it, and we need to assure us that all components are working perfectly. So there is a lot of components inside of platform, particularly operators, kamaji operator, ClusterAPI, and other stuff, and all of these pods, first of all, must be running and at least have replica number 1 or more, and then we can proceed with application level or application metrics. So let's say the pod is running, but for some reason ClusterAPI could not create a new cluster, and we should handle this situation somehow and get the information about failure before our customer will be angry.
This is a good point. I think that describing alerts for all the systems, it's quite huge work. Maybe we need to get, we have no such resources for now. So for now, we just need to decide which alerts are very important and implement them first, and then put, I know, some umbrella issue to implement alerts for the rest components.
So alerts could be very simple, like we know which namespaces are system namespaces, and all deployments that are put into system namespaces should have at least one active pod, no failing pods, and maybe something else like all nodes of Cozystack cluster should be operational, and there should not be any unavailable one.
Yeah, this one already implemented. So we had an issue with kamaji pod, which was recreating during a time, I think, according to liveness probe, didn't succeed. So we got the notification that this pod is in crash loop back off. Also, we have alerts from Kubernetes Prometheus stack that some targets are down. So in this case, if we will deploy Postgres and if it will not be working, we will know about that just from this basic alerts. So I think at least 30 or 40% of cases are covered by the basic alerts. This is good start point. We also need to add Helm releases because we actually don't know the state of them for now. And then start to implementing alerts per application.
There's some good news, by the way, related to the Flux-operator upgrade. One of the things that was included is a service monitor. So if you're not aware, the Flux-operator emits metrics with statistics about Flux resources. So Flux, in the past, Flux controllers all emitted metrics, and some of them no longer do anymore. The Flux guide has explanation of how to do monitoring with cube state metrics, which is a somewhat advanced topic in the realm of Flux monitoring. But the idea now is for Flux-operator to give you at least the bare minimum things like, are all of the Helm releases in a successful state? So it should be enough to just pull that service monitor. As long as the Flux-operator is reconciling, it will be.
Yeah, this is cool. And all those metrics are exported from KubeState metrics or from Flux-operator.
There is a the metrics that the controllers emit are updated on each reconcile interval. So the KubeState metrics are technically better if you're using KubeState metrics to monitor, because they'll tell you each resource, whether it's in a failed or passing state or not, and that may not be on the same cadence as the interval, depending on what you're monitoring. So KubeState metrics is technically better, but only in edge cases.
Yeah, thank you for this information. I'll take a look.
Okay.
Any other thoughts about alerts?
I think we should highlight that we could not build a proper set of alerts in one go, so we should finish and stay on some robust small number of alerts, and then improve it as we will learn more about how the system is operating. So it would be rather process than a product.
Yeah, makes sense. Okay, then the next topic that we internally discussed, and we decided that we need additional bundle for IDP, internal developer platform, and we would like to include such things as GitLab and Argo CD in it, and maybe also enable automatic configuration for those components. So anytime when you deploy a new tenant Kubernetes cluster, it will be automatically added to Argo CD. Or we're still considering if we should go Flux flow and use just pure GitLab and generate structure of repositories for every cluster and automatically add them just to let the users push their code into repository and to get it deployed into tenant clusters. The main question here, do you have any experience with that? If you have any ideas, you can share it right now. You can make influence actually on this implementation. I can add a little bit background to this. So for now, we have two types of customers. One of them usually reselling the services they order from Cozystack, actually cloud services. And other part of clients, they usually use Cozystack as hypervisor or as internal cloud for deploying their projects. So they usually facing with cases that they want to have standard unified way for delivering their applications and actually environments. They just want to describe single configuration file for deploying new tenant with all the needed components like Kubernetes cluster, Postgres, Redis, Rabbit, and so on. And then just deliver their code into the tenant cluster.
May I ask why you're using both Flux and Argo CD?
We are still not using Argo CD. We install it custom resource for our customers. The main reason for using Argo CD is that Argo CD has complete interface for which in love by developers. So
I want to say that the things changed just several days ago, because I talked with the guys from Headlamp. Headlamp is a very nice UI for Kubernetes, built by guys from Loco. Loco was a company that built a Flatcar distribution of Linux, and now they are like bought by Microsoft. So Microsoft invested a lot of efforts into Flatcar Linux distribution and into Headlamp. And Headlamp has a very nice UI which in fact is parity with GitOps Y. So it has all necessary stuff. Yes, Argo CD-Y would be like more convenient, and developers likes it more, but in fact, yes, there is no like Flux CD-Y in this screenshot, because it was implemented like a plugin, but in fact it would use the same set of Y primitives. So there will be a separate button on the left, Flux CD, under which you will see all Flux CD components and resources that Flux CD managing.
I think the main reason here that developers actually want really specific things, like they want to see the logs, they want to restart pods sometimes.
Everything would be allowed in headlamp, so there is no need to use a Argo CD-Y anyway.
Yeah, so you can see all the state of the deployment, and then you can use
Yes.
ordinary headlamp to manage those.
And what is more important, headlamp will allow you to drill down. So if you see some object that is managed by Flux, you can click on its name and you will go to the proper panel, like workloads, deployments, pods, or anything else. So it would create a how to say, non-disruptive UX/UI, smooth transition between different panels. And what is more important, so we are discussing a possibility to use a headlamp in multi-cluster mode. So it could give us some advantages to have a single pane to manage all entities inside of Cozystack.
That sounds interesting. I would also consider it to replace our existing KubeApps dashboard. I think it might, if it is really simple to develop the plugin for headlamp, we can at least implement the virtual machine interface for accessing it through the VNC, do reboot and power on, power off commands. That's usually expected to have in every virtualization system. And also we can implement the existing dashboard, which we're having right now, in headlamp. But I would take a look how exactly it works, and if it is really simple to add your own plugin to it.
Yeah, if what you really want is a dashboard for developers, I would not be installing Argo CD. The first thing I would be looking for is whether headlamp integrates well with authentication in the cluster. That's a bane of many dashboards. That
the answer is yes. Yes, it's easy to make a proper integration.
Okay, yeah, sounds like the way to go, because Argo CD's integration is access control rules are completely separate from the rules that you have for the developer that's using it.
So from my perspective, I've been using the headlamp Flux UI, testing it and trying it out in several different tenant style configurations. I've had a lot of success with it. I think it's great. It is still pre-release, and it is definitely an uphill battle convincing developers that they should not have Argo CD. I've had enough experience with successful implementations where they are using both Flux and Argo CD, and the main argument why Argo CD isn't sufficient is because it doesn't have perfect Helm release support in terms of hooks, lifecycle hooks, upgrade hooks. All those things are a little bit, just a little bit off. So if you tried to implement all of the operators and charts that we've implemented here in Cozystack as Argo CD apps, you would most likely...
No, Kingdom, sorry. So there is a little bit different. So we're not trying to replace Flux CD with Argo CD and trying to replace, like, I don't know, install components of Cozystack with Argo CD. The question is that Argo CD provides a nice UI, which is loved by many developers. And if we put Argo CD into platform, it can attract more users because it will have the same interface as solutions they are already using. Yeah, but I see disadvantages. Why? Because we need to support two different solutions making the same task. Flux CD, Argo CD, it's pain in the ass as usual. Yeah.
The biggest challenge with using both is that there used to be there is a solution called Flamingo that's not really maintained anymore, where if you had Flux and Argo both installed on the same cluster, you could actually monitor your Flux resources through the Argo UI. That is not really a solution that I would recommend. It's not maintained, so I wouldn't really entertain the idea of using Argo CD other than that it's great for developers. It does all of the things that we want Headlamp to do, and it is you know, an incumbent in terms of dashboard. It's the winner for a lot of people. So I think that it's great for dev users who really need visibility and hands-on control. It is not so great for ops people who really don't want ClickOps and drift in their clusters.
Yes, I see four main disadvantages with Argo CD. So as I told before, I don't like idea to support two different solutions making the same task. Secondly, Argo CD consumes a lot of memory when dealing with a bunch of objects. As Timothy mentioned, it has a separator bug, which could be disadvantage and advantage depending on what user cases you are providing, but mostly it would be disadvantage because you could not rely on a bug and tell precisely which user can have access to which objects. Also, Argo CD does not make a full compatibility with Helm, so I had a lot of questions like developer is using Helm on the local machine. He using Argo CD for deploying up to the production cluster. Then he types like Helm ls and gets nothing because Argo CD does not use a Helm engine at all. Yeah, so it does not give a proper user experience. So you need to understand what's going on under the hood of Argo CD when rendering Helm charts. And you also mentioned that Argo CD does not have a full compatibility with complex Helm charts, only with basic ones. So I think all these reasons, if we will count them, could lead us to idea that we can provide Argo CD for users that want it, but like non-supported component inside of the platform itself.
And it's not unprecedented to do this in major platforms. Like, for example, Platform 1 that's used by the US government is built on Flux CD, and it supports Argo CD for users. So
yeah, they from my point of view, they're not competing with each other, but having single ecosystem, I think this makes sense. So we already have Flux implemented in management cluster. We already have add-on for tenant clusters, and now we just need to provide simple UI for using it the same way like they get used to use Argo CD.
if Headlamp does everything and supports all of our goals, then I think we should go with it.
Totally agree.
We were looking for a nice dashboard anyway, yes. So we discussed it with Andre, and there are two winners of our internal competition. So we looked into Headlamp and we looked into OpenShift console, because OpenShift console has a integration with KubeVirt, yeah, but it's difficult to install OpenShift console on vanilla cluster. Some of functions are not working. I made this many times, I mean, installation of OpenShift console on vanilla cluster, and all basic functions are available. But anyway, it should be extended, because you won't get Flux CD objects in some additional UI, and it's not very user-friendly.
Makes sense. I just thinking if Headlamp have any requirements, I mean dependencies like external database already.
No, it's totally like monolith application. Yes, what it really just need an access to Kubernetes API, that's all. So it could be installed either on the desktop machine, and then you need to supply a kubeconfig to it, or you can install it inside of cluster, and then it will utilize a kubeconfig inside of the pod.
Can it be configured declaratively?
So it has environment variables, and you can pass additional configuration options. So if you want to use a multi-cluster setup, as I understood, you need to prepare a kubeconfig with a multiple entries with different names.
All right, so we need to create a kubeconfig and feed it to the dashboard.
Yes, but it could work inside of cluster, so it will discover service token and other stuff.
Interesting. And where it stores the configuration.
There is no configuration for
So
it.
it's just
There's some
transparent.
configuration. It's stored on persistent
It's
volume.
like OpenShift console. So OpenShift console also is stateless application. It only has a bunch of environment variables as arguments.
Can you just say that it uses persistent volume?
Yeah, I've gone to some lengths to figure out how do you install the plugins in a cluster configuration, and there are two main ways. Both are using an init container. You either build a container image that has the plugins that you want, or you use a shell script in your init container, so you don't have to build a custom image. You just fetch the plugins, but the plugins go into a persistent volume, and there is a configuration panel. I've got a thread I can post where we tried to deploy it into an OpenShift tenant, and you have to configure a few things to make it work, but there's very minimal configuration in there other than the plugins themselves.
I think that we can make headlamp totally stateless.
I would rather go this way to put all the components and plugins to bake it into the image. I just have worries that, yeah, and configuration can be probably simplest stored in config maps.
Yeah,
Well, the
yeah.
way you're describing it, this sounds quite similar to the way you add plugins to Argo CDE. And by the looks of it, we could provide a custom image that has like some basic necessary plugins, which will be launched as a sidecar next to the headlamp container.
I think we need some basic implementation just to take a look at this. I think, Georg, can you please prepare a PR with headlamp so we can consider implementation it into Cozystack?
I think that yes.
That would be really nice contribution.
You should not convince me. It's obvious.
There is no time for this task, so it's just still up to consideration. But if you'll prepare some PR that we can simply install into cluster the usual way we do, we can just consider it on the next meeting and think what plugins we want to use and how we're going to use, how we're going to organize the access to it and the rest things like that. Okay. And the rest question is, somebody had the links here. Yeah.
Yeah, I added those links there. 3 discussions about the plugin. It's not in the catalog yet, so that's the main reason why it's complicated to install. I don't think we should adopt it before it's officially published, but we can test it.
Sounds interesting. Is there any time frame when you're going to publish it, or if you know them?
I think they want to do it soon, but we've been saying soon for a few weeks now, so hopefully it will be in the next week or 2.
That's so cool. Thank you. Yeah, those charts are looking amazing. Always like this round charts. Okay, the next topic is public API implementation. We have requests from our customers who resell the services of Cozystack to their customers. They want to give access to Cozystack dashboard. For now, we think that it might be not very secure because every application can be configured all the way we provided. So we need to provide limitations like which applications should be shown to the user. It would be really nice to keep it in existing API, to keep it in stick with Kubernetes API, so we can even give access to Kubernetes API, and it will be working totally the same way as KubeApps dashboard. But the other option is that we can patch KubeApps dashboard and implement this functionality there. I still have no idea what to do better, how to do that better way. The only requirements I have is that we need to limit the set of applications going to be installed. I think we should somehow align it to the Flux-CD logic, maybe to enable multi-tenant mode, or just to cover it with the other API interface.
I think the most probably pain point here would be security, because if we are giving to the user on their back level the right to install arbitrary Helm release from which the platform consists of, it means that he can install any Helm chart existing or available to the cluster. So it could lead to installation of third-party software that we don't want to see in the cluster. It's probably the most worry from my side. Everything else is clear and looks clean. So if we will give an access to dashboard, we can restrict it to a particular namespace, and user will see only his own namespace, and he will be able to install components into it.
So we have two approaches: is implementation based on native Kubernetes API, pros and cons, possibly security issues. What's wrong with my keyboard, my fingers? Pros, native Kubernetes API, so we have all the tooling enabled. Terraform, Helm, kubectl, so on. And we can cover how to call it. In this way, we can just patch KubeApps.
Have you entertained the idea of using an external authorization server?
No, how it works?
You can configure the Kube API server to proxy some requests to an external server. And in this way, you can get not just authorization rules based on the name, the namespace, and the HTTP method you're using, as you have it in vanilla Kubernetes, but the external authorization server can inspect the entire body of the request and make a decision based on that. For instance, Deckhouse actually does that.
Is this, yeah, external auth server, is that thing you're talking about?
The quickest way to find that would be to look up the command line arguments of the Kube API server. Wow, right. Maybe I can find it quicker. Just a second.
Okay, because one of the idea was to use OAuth proxy and patch it to have transparent translation of any requests to this OEDC proxy to represent them in existing Kubernetes cluster.
The idea is not clear to me. So what you do? Because to be honest, I'm not feel comfortable with such add-ons, yeah, because if it would look like Rancherway, it would mean a separate API server, and it could be easily avoided. So if user will have an access directly to the cluster API inside of cluster, yeah, he could bypass it. But if you will implement some integration like OIDC argument on Kube API server, it would mean additional components that would stay on the critical path of the request.
Yeah, it's a sort of middle ground between rolling completely your own separate API server and going completely with the vanilla Kubernetes flow. So I just posted the relevant parameter to chat, and the mode in question is a webhook.
Mm-hmm.
Yeah, but this is only for authentication.
No. This is for authorization. It inspects the request and gives you an allow or deny, or passes it on to the next webhook, or when all the webhooks are exhausted, then to the API server.
All right. So we can implement any custom policies according to OEDC configuration. So if user could change some fields which we don't want to let them to change, they will be restricted to this. Am I right?
Yeah, I don't remember off the top of my head if it makes decisions based on the user's token or not, but it can certainly do more than just look at the name, namespace, and method.
I just thinking that this thing is, I always confuse authorization and authentication. So when we authenticate it, we authorize what user can do and what they can't. I think this will not allow you to do really strict policies for every request. It might be really expensive, but it could allow you to authenticate user using some custom way you want to implement. I know, through the GitLab, GitHub, and things so on.
Yes, but we are talking about authorization, not authentication. Please don't.
Yeah, authentication is you're just determining who the user is, or what's his username and what groups he has.
Anyway, it's an interesting approach. I would also consider another one is to implement custom resources into Kubernetes, into tenant Kubernetes clusters, so they can order resources using their own tenant cluster, and they will communicate to the dashboard and order those resources from it.
Basically, an approach like claims, right?
What do you mean?
Well, a user can create a persistent volume claim in his own namespace, and then you've got a cluster-wide resource called persistent volume that gets created based on that. Likewise, a user can create a custom resource claim in his own tenant cluster, and then the main cluster will
provision it.
Yeah, will provision it based on whatever the controller decides.
Yeah, but there is some pitfall. So let's say we have two clusters and in the same tenant, and we want to create a database with the same name from both of the clusters. So first cluster would create a database, fill all status fields, and the second cluster will get an error because the database is already pre-created, or otherwise user could want to make some adoption. So let's say not just to paste a database URL, username and password into second cluster to pass to the application, but to extract it from a already pre-created database resource. And we need to very carefully design how it should work. So when you have a resource that is in exclusive use of only one cluster, like PVC, there are no issues, with after-generated names. But if you want to control something that could be hosted, like, I don't know, API addresses, or give the user ability to set up domain names or databases name, it could work not very well. But idea of additional resources, I like it because we can implement additional custom resources on the management cluster called like Cozystack, managed Postgres, Cozystack, managed Redis, Cozystack, I don't know, managed cluster, and then transpile it into Helm release.
But do you think it should be installed in existing management cluster, or should it be managed in separate cluster for every user?
So here you are talking about crossroad, so we can choose an option when we need to give tenant users an access to the management cluster, or the users are locked only in tenant clusters itself.
I think we can use separate approach when every time when you create new tenant, you can take that you want separate Kubernetes API without workers. And then we can use this Kubernetes API with custom resources to bootstrap the user resources. And there will be allowed only to have only one of such cluster. The other option is to translate all the existing services into all Kubernetes clusters. But I like the first approach more. So we can create empty API server, which can also be configured with OEDC and with all the parameters the user need. And then just create a controller which will sync the data from this API server into management.
Yes, but why not to look? It's very complex. Why not just to give access to the root Kubernetes API server? Why you need an additional API server in each of tenants? Then you can aggregate them into one entity.
I just think it might be a security issue. I don't know.
Look, it's the same security issue that every public cloud has. Like, let's say, you don't create a different API entry points for different users for public clouds, but rather give you only one endpoint and check user rights and give user only permissions to create objects only in one of the tenants.
I have a fear, for example, we can add, they might want to use Helm charts. Helm charts are always willing to store the secrets in the same cluster, and they can be really huge. I think it always.
I think that we should come from another end, so we can write down all our fees, all drawbacks of every solution, and then choose the least evil.
That makes sense.
Because otherwise we will just sink into discussion what is a proper way to to implement it. So again, from the experience from public clouds, you don't have every endpoint for every user. You have a single endpoint with a single control of permissions.
There might be also option that we can create a single Kubernetes cluster, which is tenant one, and give it to the users. So it will be Kubernetes cluster, which will dedicate it only to have public API with no workers, and will be secured from giving access to management cluster API itself. Okay, let's think about that later. I think I will collect the more information about every approach and will provide some research or design doc how it could be in every specific way if we choose for implementation. Let's switch to the next topic, and the next topic from Marian. Marian, would you like to introduce it?
Sure. I often rebuild some parts of Cozystack cluster, sometimes add new workers or remove them. And I need some maybe expanding functionality for ClusterAPI, for using some other providers like AWS or vSphere or Hetzner, and I think how about extending this in current configuration capi-provider helm chart?
I think that might make sense, but can you describe the user story more? Like what you're trying to do is to provision workers in Hetzner with ClusterAPI provider, am I right?
Yep, because for Hetzner Cloud, we have a fully functional copy provider, and we can get new virtual machines over this provider.
I think we need to consider how you and how do you want to order those virtual machines, and how do you use them for as virtual machines or as Kubernetes workers?
As Kubernetes workers, mainly.
All right. So you want to make Kubernetes working. Yeah, that might be interesting idea that we can have Cozystack, which provision control planes and allows you to order the workers, not from KubeVirt only, but also from Hetzner, from VMware.
Because this plugin can implement this, and we can provision and get this virtual machine and delete them.
I think this can be done in a specific hosted Helm chart, hosted bundle. So in Cozystack, we have various bundles, and we have PaaS hosted bundle. For now, it allows you to bootstrap Cozystack on existing Kubernetes cluster. It might be interesting to extend it with specific provider. For example, if you deploy Cozystack in AWS, you can add the option here that you're going to use AWS provider. And it will also enable you opportunity to bootstrap Kubernetes workers in the same way like we do right now with KubeVirt.
Yes, but the issue is the connectivity between control plane and remote workers. How we would achieve that it would be working?
I think this should not be an issue. because from connections from control plane to workers managed by Kamaji, so you only need to have publicly accessible Kubernetes API. So this should be working out of the box. I don't know. I think we need a proposal for this feature. So if you're going to use it, to implement it, you can try to extend one of the existing bundles, and we can try to align it to make it working. That really sounds something that we want to have and support in the nearest future.
Okay, yeah, I'm preparing issue and PR with implementing for Hetzner Cloud.
Thank you. Ruben, do you have a question? You're on a mute right now.
Oh, I'm sorry. Hello, everyone. I just want to add some information about the last topic that we were talking just now, because last time when Marian told me about ClusterAPI and all the stuff, I just make some little research. And for example, I've just shared now in our messages link to the ClusterAPI provider for Hetzner. So I must have some meeting in these days with them, because the task I want to achieve is, for example, I'm bootstrapping now Cozystack with Talos on bare metal Hetzner machines, and I want to make some later autoscaler which will bootstrap some other Kubernetes machines like workers, for example, on Hetzner Cloud. So one of the difficulties is that, for example, when we can use some tool which can make that ISO for the Talos in order to be bootstrapped in our Hetzner Cloud is, I guess it's easy. But for example, to bootstrap Talos on bare metal, there are some difficult. And for example, Hetzner has also some great feature like Hetzner Way Switch, where we can connect all that connect bare metal and cloud servers in some virtual network, so they can already talk to each other inside of Hetzner, not via the public IP addresses. So I just shadowed some meeting with these guys because I just want to understand how they can help me to make this architecture, and if I have more information of them, because I think that this is one of the most popular API infrastructure providers for ClusterAPI in Hetzner, I will definitely share with our community.
It's a nice idea. I like it very much, and you are not the only person who asked me the same. I know that we have a lot of guys in Talos community who are using hCloud, Hetzner bare metal service, or even both of the technologies. And unfortunately, there were not still some demand from these guys to use Cozystack, and probably it would be nice to make their lives easier and provide some automations and integrations to allow usage of this hybrid infra.
Yeah, I think also we should consider replacing native KubeVirt VirtualMachine by ClusterAPI machine resource. If we will enable this support for adding additional providers for providing for running virtual machines, actually workers in different platforms, that would enable us to provision virtual machines the same way we do using ClusterAPI. So this is just up to consideration. Timothy, you have
Yeah, I have some experience toying around with some machines running with an OpenStack cloud controller manager, and trying to join some separate unmanaged workers to the cluster. And one thing that happens is that the cloud controller kicks these nodes out of the cluster immediately. And if I recall correctly, this functionality is in the upstream Kubernetes code. So one issue that we might have to tackle if we want to go with some multi-cloud, with some multiple providers for the nodes, is possibly even rolling our own interface for the cluster API. So similar how say there's a CNI plugin called Multus that enables you to use multiple CNI plugins. You might have to write a cluster API controller that enables you to use multiple downstream cluster API controllers. The way I would word it is not that we can write, we might have to write.
I thought that such a cluster API provider was already created, and let me check. I thought that Talos provides something similar, not?
They had some cluster API provider, but it is not maintained anymore. They just accept community contributions to it, and they fully switched to provision clusters using Omni. So anyway, we are 3 minutes more. Let's finish our call, and I will put this discussion to the next meeting so we can continue in 1 week. So see you in 1 week in the same time. Thank you. Thank you for this amazing meeting. Bye-bye.
Andrei?
Bye-bye.
Yep.
Would you have a